Okay, so hi guys, welcome to my next video. In this video we are going to discuss about superposition of forces. Okay, and in previous videos we have seen some numericals which you might have solved. Okay, so without passing our time, let's begin with the topics. Okay, see, superposition of forces. What happens in superposition of forces? See, let Q1, Q2, Q3, Q1, Q2, Q3 Qn. So many forces are the so many charges in a system with position R1, R2, R3 having respective positions and Rn. Okay. Suppose a charge Q0. Suppose a charge Q0 is placed at position R0. Okay. At which total force going to be estimated. Okay. See, Q1 and the position R1, R2, R3 and R3 Q3 हो जाएगा, ये Q2 Qn तक हम लोग आएंगे. Suppose having position R0, Q0, there is a charge Q0. Okay, we have to calculate force on Q0. Okay, then according to this superposition principle, the force experienced by this Q0 is equal to the vector sum of the force due to individual charges. The vector sum of force experienced by Q0 due to individual charges. Okay, so what we could say that the force, total force, is F naught, the force on Q0 due to Q1 charge. You could see dot dot dot. Okay, that will be a vector sum. Okay, so this concludes the superposition of the forces. Okay, now we are going to discuss about electric fields. Okay, the next topic, electric field. Okay, now see, what is electric field? We are in class 12th, so we have studied about magnetic fields. What we do, we have kept a magnet, and we have done some lab experiments also. Okay, but here we have to keep a charge. Okay, let it be Q. Okay, let it be capital Q. That might be a source charge. Okay, so how we define electric field? We define electric field as a region around a charge, where another charge experience a force. Let another test charge Q. Okay, the region around a charge where another charge experience a force. See, the charge started experience force from here, so that's charge doesn't experience force from here. So the region from where another charge experience a force due to the source charge, that region we call electric field of this. Okay, so electric field is measured in terms of electric field intensity. Now what is this term? Electric field intensity. Electric field intensity. Okay, see how we define these words. We should take care of these words. Okay, we measure electric field in terms of electric field intensity. We define it as the force experienced. The force, listen me carefully, the force experienced by per unit test charge in electric field. See, the force experienced by what is intensity? The force experienced by per unit experienced by a test charge per unit. Sorry, we could define the force experienced by per unit test charge in an electric field is called electric field intensity, and then denoted by this. Okay, so electric field is a vector physical quantity. Okay, keep the things into mind. Okay, so let capital Q, which we have considered, be a source charge, and small q be the small test charge. We should keep a test charge always small. Okay, so what we write is intensity, that's electric field intensity, is equal to limit q tending towards 0, q tending towards 0 if by q. Why I have written this? Because we have to keep the test charge as small as possible, that q tending towards 0, such that the position of source charge could not be disturbed by this test charge. Okay, so again what we do is, see, E is equal to K Q by R square. I have written directly this. Now see, keep the value of F here. You will left with this formula. Okay, put the value F. What is the value of F? K Q by R square into Q, and Q cancel out. So we left with E is equal to KQ by R square. Okay, keep this formula in mind and keep some definition, just like what is electric field, what is electric field intensity. Once again I define it. Electric field intensity is the force experienced by per unit test charge in electric field is called electric field intensity. It is a physical vector physical quantity. Okay, these things should be kept in mind. Okay, now see, if we have to determine the direction. Okay, now see, if the source charge is positive, the direction of field at any point will away along the line joining the charge. See, along the line joining the charge. See, what I have told, that if the source charge is positive, let it be Q, that is positive. See, at the test charge, if the source charge is positive, then the direction of field is away. Line joining, see, this word is very important. This line, the direction of field at any point will be always along the line joining the charge and the point. Okay, and if it is negative, then that will be always, suppose we have to calculate what this point P, okay, we have to calculate the electric field at this point, okay, and at this point we are talking about that point, okay. So if the source charge is positive, then it will always along the line, keep this along the line in your mind, along the line, because in the next chapters we have to see the difference between Coulomb's law and Biot-Savart's law, I think, okay. So that is clear, I think, okay. So see you in the next video with some numericals on electric field, okay. Thank you.